All right, so let's talk about what we went over at the board in class. We talked about mole ratio today, and I used the example of a brownie mix. And I may have drawn this on the board. You know, if you go and get a packaged brownie mix, the recipe has the powder, and then you have to add 2 eggs, maybe 3 eggs. You have some oil. In this case, we're saying 1/2 cup of oil, and then some water. We have 1/3 cup of water. And I asked you, if we were making 3 batches, how many eggs would we need? And so some of you were able to say, okay, well, 3 batches, each batch contains 2 eggs, so then there would need to be 6 eggs. And we could do the same for the oil. If we were making, let's say, 2 batches, and we wanted to know how much oil we would need, we would look back here. Well, each batch is 1/2 cup of oil, and if we were doing 2 batches, we multiply that by 2, and we would need then 2 1/2 cups, which would be 1 full cup of oil. So you can use the recipe as a ratio to determine reactants needed or products depending on what you're being asked to solve. So we can take that a step further, and we can look at a balanced chemical equation, and we can predict the same information. You look at the balanced chemical equation here, and you are able to say, all right, every time we have 2 moles of Al2O3, we can equate it to 4 moles of Al, which we've shown in a fraction here. We can also say 2 moles of Al2O3 are also equal to 3 moles of oxygen, O2, and that's shown in this fraction. And we can also then go between these two, which we haven't compared. We have 4 Al and 3 O2. Now, the flip side is that we wrote the fractions with the Al2O3 on the top, but we can write it upside down. We can say 4 moles of Al and 2 moles of Al2O3. And we can do that for all of them. Here, I'll flip this one. We would have 3 moles of O2 and 2 moles of Al2O3. And this last one, we can say 3 moles of O2 and 4 moles of Al. We got all of this information. All 6 of these fractions come from your balanced chemical equation, which is telling you the ratios that compare in this particular recipe. Think of this like our brownie recipe. This is our recipe. As IEP. Well, I can't spell, and we all know that. Recipe. And this is how we make this Al and this oxygen from Al2O3. And it has to be in this ratio. So deciding which one of these fractions to use is dependent on what information they give you in the problem you're trying to solve. But all of this information can be interpreted from this balanced equation. So if you go the whole way down here to this practice that's on the example that we have here, this practice, we have this balanced equation here, N2 plus 3H2 makes 2NH3, and they give me some information. They tell me that I have 1.75 moles of H2, and I'm being asked to figure out how many moles of N2. Now, we haven't done conversions in a while, but you're going to take the 1.75 moles that they gave us of H2, and remember when we did these problems we always put them over 1. Now we are going to convert this into some number of moles of N2 because this is what it asked me to find. I have information in my balanced chemical equation. I have information that relates N2 to H2, N2 to NH3, and then H2 to NH3, but I don't need all of it. I only really need one piece. I need the piece that goes from H2 to N2. Okay, and if you look up here, I know that I have 3 H2s for every 1 N2. Deciding where things go in the fraction is something we've done before. We've always taken whatever unit is here on the first fraction, that unit goes on the bottom of the next one. So moles of H2 will go on the bottom, and then we're going to use the number from the balanced equation that goes with the H2. In this case, it's 3, so we'll put the 3 there. And we are going to relate it to the N2, which is what we were asked to find, and we see that there is 1 mole of N2 in our balanced equation here. There's no number written, so that's an understood 1. So now we have the unit that we were asked to find. If you look back, we can cancel them. We cancel the moles of H2, we can't cancel this, so we're left with this as an answer. And when you take your calculator now, you're going to take the 1.75 and you're going to divide by 3, and you get an answer of, I had an error on my calculator, I typed something wrong. So we're going to get an answer of 0.583 3 moles. So we have 3 sig figs here, we have 3 there. So the answer is 0.583 moles of N2 are used when we use up all the moles of H2 that were given. So that's just a review of what we did yesterday in class.